Hi, I'm Matt, and in this video we're going to talk about how to take certain trig derivatives, more specifically the derivative of secant, cosecant, tangent, and cotangent. If you've seen my videos before, this video is going to be a little different. Rather than me giving the rules for these functions, here we're actually going to derive where these rules come from using chain rule, quotient rule, and a few other rules. So here are the important rules that we're going to use in this video to derive these four derivatives. So the first one is the derivative of sine. The derivative of sine of g of x is cosine of g of x times g prime of x. The derivative of cosine is going to be the negative sine g of x times g prime of x. The chain rule is going to say that d dx of g of h of x is equal to g prime of h of x times h prime of x. And finally, we have our quotient rule, which says that d dx of g of x divided by h of x is equal to g prime of x h of x minus g of x h prime of x, all divided by h of x squared. Again, these are the four rules that we're going to use to derive the trig derivatives. So the first one we're going to do is secant of x. So we want to find the derivative of secant, or more specifically d dx of secant of g of x. But now we're going to want to rewrite secant of g of x in a way that we could work with it in terms of the four rules that I've already mentioned. So what we're going to do is first use that secant is 1 over cosine. So the derivative of secant of g of x is going to be equal to the derivative of 1 divided by cosine of g of x. And now after that, I'm going to bring cosine up to the numerator and use a negative exponent. So we find that the derivative of secant of g of x is going to be the same as the derivative of cosine of g of x to the negative first power, as written here. So now we see that we have a function and it's being raised to an exponent. So here we're going to want to use the chain rule. Remember that the chain rule says that d dx of g of h of x is going to be equal to g prime of h of x times h prime of x. So now we need to identify what our inside and our outside function is. So our inside function, or our h of x, is going to be what's typically written in parentheses or brackets. I'm going to take the inside function to be cosine of g of x here, because again, that's what we have inside the brackets. And now g of x, or our outside function, is going to be what's ever done to what's in the brackets. So here g of x is going to be x to the negative first. Using power rule, we find that the derivative of x to the negative first is going to be negative 1 divided by x squared. Now, the derivative of h of x, or h prime of x, is what I gave at the beginning of this video, and that's just the rule for cosine. So h prime of x is going to be negative sine of g of x times g prime of x. So now that we have this, we just need to find g prime of h of x. So g prime of h of x, we're just going to plug in cosine into g prime of x, and this will give us negative 1 divided by cos squared of g of x. So now we could plug in what we have here using the chain rule into what we had up here. So now we're going to have that d dx of cosine of g of x to the negative first power is going to be equal to g prime of h of x. So that was our negative 1 divided by cos squared g of x times h prime of x. So h prime of x is going to be negative sine of g of x times g prime of x. And now we just need to simplify. So first we'll cancel out the negatives and just have sine of g of x divided by cos squared of g of x. Now I'm going to write it as cosine of g of x times 1 divided by cosine of g of x, and then times g prime of x. The reason I wrote it this way is that the first term here can clearly be seen, since it's sine divided by cosine, to just be tangent of g of x. And then here we see that for our second term, this is just secant. So we're left with secant of g of x. And therefore we have found for our final answer that d dx of secant of g of x is going to be equal to tangent of g of x times secant of g of x times g prime of x. And again, that is our final rule for the derivative of secant. Next, we're going to look at cosecant of g of x. And this is a very similar procedure to the previous one. So the first thing we're going to do is just write what we're trying to do. So again, d dx of cosecant of g of x. And remember that cosecant is 1 divided by sine. So we'll rewrite this as d dx of 1 divided by sine of g of x. And then again, we'll bring that sign up to the numerator and make a negative exponent to get that the derivative of cosecant of g of x is the same as the derivative of sine of g of x, all to the negative first power. So now that we have this, we see we again have a setup for chain rule because we have an inside function and then something being done to it. So again, chain rule says that d dx of g of h of x is going to be equal to g prime of h of x times h prime of x, where h of x is our inside function and g of x is our outside function. So just as in the previous slide, our inside function is going to be our trig function because it's the one nested inside parentheses. So we'll have h of x is sine of g of x. And then our outside function will be whatever being done to sine of g of x. So our outside function will again be x to the negative first. As said on the previous example, g prime of x, it can be found using power rule to be negative 1 divided by x squared. And now we also need h prime of x. But h prime of x is just the derivative of sine, which is one of the rules I gave at the beginning of the video. And the derivative of h of x is going to be cosine of g of x times g prime of x. And now the last thing to do to plug into the chain rule is that we need to find g prime of h of x. And to do that, we just need to plug in h of x into this equation. So this will now be negative 1 divided by h of x squared, because again, we're subbing in h of x, or negative 1 divided by sine of g of x squared. Now that we have g prime of h of x and h prime of x, we can now plug into our chain rule, which says that the derivative of sine of g of x, all to the negative first, is going to again be equal to g prime of h of x. So negative 1 divided by sine of g of x to the squared, and then multiplied by h prime of x, or cosine of g of x, times g prime of x. And now from here, it's just a matter of simplifying. So just as we did before, I'm going to break up the square. So we'll have negative 1 divided by sine of g of x times cosine of g of x divided by sine of g of x multiplied by g prime of x. And now we see that we have some trig identities. Negative 1, or just 1 divided by sine, will be negative cosecant of g of x. And then cosine divided by sine will be cotangent of g of x. And with those simplifications, we could write our final rule as d dx of cosecant of g of x is going to be equal to negative cosecant g of x times cotangent of g of x times g prime of x. And that is our rule. Now, for our third trig function, we're going to take the derivative of tangent of g of x. So again, we want d dx of tangent of g of x. However, we again need to write tangent of g of x in terms of something we already know how to work with, mainly those 4 rules at the beginning of the video. And what I'm going to do is I'm going to rewrite tangent as sine divided by a cosine. So we'll have the derivative of sine of g of x divided by cosine of g of x. And now we know the derivative of sine and cosine, and we have them divided by each other, so we're going to use quotient rule here. Recall that quotient rule says d dx of g of x divided by h of x is going to be equal to g prime of x h of x minus g of x h prime of x, all divided by h of x squared. Just a quick note, the g of x I'm writing in the general quotient rule is different from the g of x inside the tangent function. I apologize for the notational confusion, but again, those g of x's are not necessarily related. So now we need to identify what g of x and h of x is. From the way we wrote quotient rule, g of x is going to be our numerator, so g of x is going to be sine of g of x. And then h of x is going to be our denominator, or in this case, cosine of g of x. So now to plug into quotient rule, we need g prime of x and h prime of x. Luckily for us, the derivative of g prime of x and the derivative of h prime of x are both given in the rules at the beginning of this video. So the derivative of sine of g of x is going to be cosine of g of x times g prime of x. Somewhat similarly, h prime of x is going to be the derivative of cosine, which is going to be negative sine of g of x times g prime of x. Now that we have all four pieces involved in the quotient rule, we can plug in. So we get that d dx of sine of g of x divided by cosine of g of x is going to be equal to, so g prime of x is cosine of g of x times g prime of x. And then h of x is going to be cosine of g of x. And now we have minus g of x, which is sine of g of x, times h prime of x. And we said that h prime of x is going to be negative sine of g of x times g prime of x. And then that's all going to be divided by h of x squared. So h of x squared is just going to be cosine squared g of x. And now we're definitely going to need to simplify this. So we're going to have that d dx of sine divided by cosine, or d dx of tangent of g of x, is going to be equal to, for the combination of the first term, we see that we have a cosine and a cosine. So we're going to have cosine squared g of x times g prime of x. And then the minus here and the minus here are going to cancel, and we're left with a positive sine squared g of x times g prime of x, all now divided by cos squared of g of x. And now to simplify this further, we see that we have a cosine squared and we have a sine squared. Cosine squared plus sine squared is 1. So when we write this as cos squared g of x plus sine squared times g of x in parentheses times g prime of x, we see that in the numerator, we're just going to be left with g prime of x. So again, this whole first piece here simplifies to 1. And this then leaves us with d dx of tangent of g of x is going to be equal to g prime of x divided by cos squared of g of x. And now the last thing we're going to want to do is bring up the cos squared to the numerator, since 1 divided by cosine squared is secant squared. And this gives us that d dx of tangent of g of x is going to be equal to secant squared g of x times g prime of x. And again, this will be our rule for tangent. Now, finally, we're going to take the derivative of cotangent of g of x. So again, we're going to start off by writing d dx of cotangent of g of x. From here, we have two options. We could either write cotangent as cosine divided by sine, or as 1 divided by tangent. For this one, I believe that it's a little bit simpler to side with the latter. So I'm going to write d dx of 1 divided by tangent of g of x, and then bring tangent up to the numerator to get d dx of tangent of g of x all to the negative first. And now we see that since we have a trig function, or we have a function inside parentheses with an exponent, that chain rule is going to be helpful here. So what we're going to do is we're going to write our generic chain rule. So d dx of g of h of x is going to be equal to g prime of h of x times h prime of x, where again g of x is our outside function and h of x is our inside function. So in this case, h of x, or our inside function, is going to be the trig function as it's inside parentheses. So h of x is going to be tangent of g of x. And then g of x is going to be whatever being done to the tangent of g of x. So in this case, to the negative first. So g of x will be x to the negative first. As used before, the derivative of x to the negative first is negative 1 divided by x squared. And now for h prime of x, or the derivative of tangent, we just need to take the result derived on the previous slide, that the derivative of tangent of g of x is going to be secant squared g of x times g prime of x. Now that we have this, we could find g prime of h of x, as that is the piece in the chain rule. To do this, I'm going to plug in h of x into the derivative. So we'll get negative 1 divided by h of x squared, which just gives us negative 1 divided by tangent squared of g of x. Now that we have these two pieces, we could plug into our chain rule, which says that d dx of tangent of g of x, all to the negative first power, is going to be equal to g prime of h of x, so negative 1 divided by tangent squared of g of x, multiplied by h prime of x, which again, h prime of x in this case is going to be secant squared g of x, times g prime of x. Now that we have this, we just need to simplify. So what I'm going to do is I'm going to break everything up in terms of sine and cosines here. But first, I'm going to rewrite this as negative 1 cotangent squared g of x times secant squared g of x times g prime of x. I'm then going to rewrite this now as d dx of cotangent. So again, the derivative of cotangent is equal to negative cosine squared g of x divided by sine squared of g of x times 1 divided by cosine squared g of x times g prime of x. And what we see is that our cos squareds cancel out, and we're just left with negative g prime of x divided by sine squared g of x. However, we know that 1 divided by sine is cosecant, so 1 divided by sine squared is cosecant squared. So from that, we do one more simplification to get our final rule, and that says that d dx of cotangent of g of x is going to be equal to negative cosecant squared g of x times g prime of x. And this on the bottom will be our final rule. So now that we've derived all four, I'm just going to write them here for clarity. And I would suggest you memorize these rules so you don't have to derive them every time. But if you do want to do a quick check, these derivations can be very helpful. So again, we found that the derivative of secant was secant g of x tangent g of x times g prime of x. The derivative of cosecant of g of x was negative cosecant of g of x times cotangent of g of x times g prime of x. We found that the derivative of tangent of g of x was secant squared g of x times g prime of x. And finally, we found that the derivative of cotangent of g of x was negative cosecant squared g of x times g prime of x. That being said, that was all I had. Well, feel free to leave any questions you have in the comments below. Thank you so much for watching. Have a great day.